Have a few highlighters ready. Okay, what did I tell you? When you think of weighted mean, you're usually going to be faced with some sort of table, not always, table with categories, okay? And there will be one category that we call repetition, and then there's one category that has percentages. I just do that. Textbooks don't do that, okay? I just split it into these two categories. You will probably notice that you end up treating them the same way, okay? When you think of weighted mean and you see that table, I want you to get mad, right? Not at me, get mad at the question. Right? So MAD stands for we multiply, then we add what we multiplied, the products, and then we end up dividing by something. Okay? And so my first category is the percentage one. That's the one I covered on Friday. And what does that entail? When you see percentages, because it doesn't always work out to 100. Trust me. Like sometimes you have percentages and it will not add up to 100. But if it does, if you add up the rows and one of them adds up to 100, right? After you add up your products, you just go ahead and divide your answer, your final answer, by 100, and then you get your final, in this case, your final average, right? In this case. And this is a weighted mean scenario. And then I asked you to try a few. So we went to page 40, right here, and we did the devices. And I asked you to add these, so the first row represented the devices, and the second row represented the number of households, in this case percentage of households with their respective devices. So you can tell this is a frequency table, okay? It's not just a bunch of numbers. They're not in the same category, right? They're different categories. Then page 40, I don't know if you had time to copy this down, but this is one that did not have a table. So I will actually put a heading on the top here of this question. There's no table here, but this is a weighted mean situation, okay? So we made our table. We put the 4 tests in place, what we scored on every test, and what the weight was for every test. And then we did the same thing as before. We multiplied, so you can do that part. You add it all up, and we got 8,090. And then we had to decide what to divide by. You will always have to divide. And why did I divide it by 100? Because the weights, that column in this case, did add up to 100. So I decided to divide my total by 100. You get the mark there. Okay, now let's go to the repetition part. I don't know if you did 41. I'm just going to give you the answer for 31 in brackets if you want to try that one. You're supposed to get 392. Sorry, not point, just 392 flat dollars per customer. Okay. How many of you did do this question? Did any actually do this one? Most of us haven't. Well, why don't we do that right now before I move on to the next one, just to get one more try at it. A long weekend has gone by. Figure out the mean spending rounded to the nearest dollar per customer. And this is a percentage scenario, so just follow the steps that I have in my notes. So do the MAD part. This one, again, I don't like this one too much. I am recording. I don't like this one too much because it doesn't have the 2 headings, but usually they do. So we'll just go spending in dollars, and this would be customers here. Split it up like that. I don't know if you can see that. So spending is at the top, customers at the bottom. So let's figure out what the mean or the average spending has been for this in this particular store that sells computers. Give that a So this is what you get when you multiply. So to find your average, you add all of this up and you get 39,200. Okay. And then we have to decide what to divide by. And anybody check already? This, if you add up the percentages, I'm just gonna say that it adds up to 100. Just follow along now, okay? Divide it by 100, and so that is $392 dollars per customer on average spend at the store. And I want to introduce the unit analysis here. What were you multiplying every time when you were multiplying across? It was dollars times percentage. Can you knock them, please? Okay. Dollars times percentage. And when you divide it by 100, that was percentage. Okay? That was percentage. So when you cancel, when you divide by 100, which is, this is percentage right there, you cancel out the percentages, which leaves you with dollars. That's why you know that your answer should be in dollars. Okay? Now, let's do the repetition example here. That we're gonna, let's call this what it is, unit analysis. Okay. So you're basically doing a little side thing to figure out what unit should remain. Okay? Let's go to 44. So I'm gonna skip the backwards for now. I'm gonna take us straight to 44. So weighted mean involving repetition. And this is what repetition is talking about. You see a bunch of 3s, a bunch of 4s, 7s, 9s, and so forth for this data set. And it's number of shoes over an 18-day period, right? So to figure out the average, we would normally just add up all of these values, which is very tedious, and you end up with, let me just get that number, um, 110. If you add this up individually, it's 110, and you've added up 18 values. So if you divide this, you get 6.11 shoes. I know it sounds weird, but right, we want to compare, you know, this 18-day period with another 18-day period perhaps, and if this number goes up, we know we've sold more on average. But there are two ways. This is number one, right? First method, which I don't want you to use in this case, and this is the weighted mean method. It's just the way you calculate, okay? The answer will not vary. It's just the way you calculate it. How many 3s do we have? We've got 3 of them. How many 4s do we have? We've got 6 of them. There are 2 7s and how many 9s? 7, yeah, thank you. So this is where weighted mean comes in. Remember MAD? Okay, so we're going to figure out our average. So we're going to go 3 times 3, 3 times 3, plus, we're going to go 6 times 4. It's just faster, right? Plus, there are 2 7s, so you go 2 times 7. Plus, there are 7 9s, so you go 7 times 9. And how many values are we adding up again? It doesn't change, right? We're still talking about 18 numbers. So that's 18. Okay. If you break this down, 3 times 3 is 9. 6 times 4 is 24. You've got 14. You've got 63. All of that divided by 18. Guess what? You're still going to get 110 at the top, and you're going to divide by 18, which is still going to give you 6.11 shoes. This is the backdrop of what's happening moving forward. Instead of us doing this, which is very tedious, we've got repeated items there, right? And adding it all up individually is going to be very time consuming. So we're going to resort to the weighted mean method of solving things. In fact, you cannot even do this every time, right? It'll be so time consuming. We're going to go over to weighted mean. So here's the first example, okay? Example number 1. Question. Is this a weighted mean scenario if you look at it? Yes, because you've got number of students. Okay, and let's give it a different color. We've got number of hours studied. Okay. We've got different categories. You've got hours studied, numbers of students. So these numbers are not in the same category, guys. Don't be adding 120 plus 3 plus 280 plus 4. That'd be wrong. Okay? So it's a weighted mean situation. Weighted mean different categories. You can even say headings, right? The headings give it away. So we're going to resort to MAD. Should probably do a different word, right? But that's all I can come up with. So the first thing is multiplying, and you multiply across categories. So in this case, it's a vertical table. No problem, we'll multiply this way. So multiply, 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 right? So we're multiplying across that way. So times, 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 times. So we're going to go 120 times 3, which is 360. 280 times 4, that's 1120. 90 times 5, which is 450. 30 times 6, which is 180. Now let's add them all up. That was the second step, right? You add all of these values up. You get, if you do that, you get 2,110. Okay, so we're ready to do our final, this is our final approach here. The 2,110, that's the number that goes on top. And it's the division that's going to give you a harder time in this one. Okay? Question, what were we multiplying this whole time? What are the 2 units we were multiplying? Students. Right? Write this down. Times hours studied. And we want to get rid of one of these 2. We only want one of them. What is this question asking us for? To calculate what? Average number of hours studied. Correct? So we want this to stay. So what do we have to divide this thing by to be left with hours? We want to divide by students. Not 18 in this case, but I know what you're trying to say. You're going back to the previous example, right? Students, yeah, you want to divide by students. Because then you get to cancel that out. I'm going to use a red pen for this one. The canceling out part is important. Which column is going to give me the total number of students? It's kind of like a giveaway, right? This one right here. How many students were part of this survey? Somebody added already? 520. So when you add up all of these, you've got 520 students. If I were to add this column, I would just add up the number of hours, which I don't care about right now. I just care about the number of students, okay? So this is the number you have to put down here, the 520. Okay, because that's going to allow you to cancel out. So this is students. Okay, write down, make sure you have students there. And that's going to cancel out the student unit that is up top here. That's part of that number right there. So let's figure out our final. Final answer is this divided by 520, which is 4.06 hours. Okay, so on average, students study about 4 hours or so. Not bad. Okay, let's add up this one. What does this add up to here? This column, 4 and 3 is 7. That'd be 12, 18. Oh, that's why you said 18, right? Okay. So in this case, that is not what you would want to use. Okay. Because then you would cancel out hours being left with students. So what happened, just look up here. It's important that you understand this because you may be on an exam and you might add this up, which is 18. Let's divide that by 18. Would it make sense for students to study on average 117 hours? I mean, that'd be awesome, but there isn't even enough time in a week to get that done, right? So that's sometimes where you know, wait a minute, this column cannot be it. Like it just doesn't make any sense. I'll try the other one, right? I'll try the other one, see if that makes more sense. Because what are our hours studied? Our lowest is 3, our highest is 6, right? So our number that we're expecting to get should be somewhere in between the high and the low, okay? What else? Okay, I just want you to understand, what is this table saying? 120 students responded with 3 hours that they studied. 280 students responded saying they study 4 hours, and so forth. So can you imagine me making a list like this with each individual response? So like 123s. So can you imagine adding up 123s? Plus 3, plus 3, plus 3, plus 3. And how do you know if you didn't miss one, right? So it's not practical. That's why you want to use weighted mean. This is the format, okay? Let's go over to 45. You know what? I'm going to skip 45 and 46 for now. I will ask you to go to 47 and try that one, because that's a table. Not always will you have a table, but the majority of cases you do have a table. Go to 47. I want you to try this. I'm not even going to give you the answer for now, because it's okay to get it wrong. Okay, guys? It's okay to get it wrong. What is this question about? 47. Ticket prices for a festival, right, are as follows. If there's 125 children, so almost imagine at first no table. Could you make one yourselves if you didn't have a table, right? So this is how many people actually attended per category. And it's asking, what is the average price per ticket? Okay, that's what you're trying to figure out. Question. Look up here before you start. What are my ticket prices? What's the lowest? 12, the high is 18, correct? Should your ticket price be less than 12 or more than 18? Can it be? Cannot be. So let that be a guide to see whether or not you're doing things right. Okay, how about a couple minutes? Give it a try. All right, so if you did this right, page 47. So if you multiplied everything first, knowing that there are categories, right? So how do you know it's not a weighted mean situation? If there are no categories, like if you just got a table like this, with just a bunch of values, right? So then you don't want to see this as a, I'll give you another example after this. Let's do this first. So when we multiply, you get 1,500 for this. You get 3615 for that one, 6,075, 5,904. Okay, so that would get you 1 mark already if you have this step right here. It's usually worth 2 marks. And then we do the mean, right? So adding all of this up gets you 24,594. Okay, that is all of this added up amounts to that. And now the last thing is to decide what you're going to divide by. I call this units or unit analysis. What did you multiply every time? You went price times attendance, right? And you want this to stay. It's asking for the average price. So you want that to stay, meaning you have to divide by attendees or attendance in order to cancel out. Okay. So this tells me to go and find that number, right? So add up all the people that are attending. That ends up to 1,237. You take that number over to this calculation here, divide it as you see there, and you end up with $19.88 per ticket. Okay. So why is it that you want to do that? Right? Well, you might compare to another festival or another somewhere else, like what the average ticket price is somewhere else. So you can say like an average it's lower here compared to another place, right? Question: what is the mode of the ticket price? The mode. You can answer that. The mode. Which ticket price is most common? What's that? 25. 25 is the most common. Why? Because you have 543 people paying that amount, right? So I can add that here. Note that the mode is $25. Okay? 543 times would it show up on in your list. If you, like, obviously someone kept track of every single ticket, right? The system does. And you just clean it up in a nice, put a line here. Put a line right there. Not a weighted mean scenario. I want to tell you, when do you not go weighted mean? Because that's kind of like I end up with weighted mean, and some students think every single table they ever see is weighted mean. Mad, right? It's everywhere. So let's say you have something like this, test number 1. So this is be your tests. So first test, second test, third test, and your score. Let's say you scored 75, 60, and 75 again. This is not a weighted mean scenario. Don't be going multiplying like this, because in this case, I'm saying that test number 1, I scored 75. On test number 2, I scored 60. test number 3, I scored 75. So it's not saying there's one test where someone scored 75, 2 tests, somebody scored 60, right? So it's not that. So you have to read carefully whether or not it's intending repetition, okay? All right. I'm going to pause here a little bit and give you a chance to try a couple more questions where there is not a table. So circle with me. Go to 45. I want you to circle. And I know you're tired after the weekend. You still got to kind of get on it here. 45, go to the very top, the tips there. You don't have to do 2 different methods. Just calculate the mean tip, okay? That's all I care about. Calculate the mean tip for 45. Then we're going to go to 46, and I want you to try 8 and 9. You can make yourselves a table if you want, but circle 8 and 9 as well on 46. So those are the 3 questions I would like you to work on before I do a different example, okay? There's still backwards examples. So for now, just focus on that, okay? Back to 42, weighted mean backwards. What does that mean? The mean is given, okay? It's already provided. Not much more new stuff, guys. Just hang in there, okay? So, Addy wrote 3 math tests, each worth 20% of his final grade. He got 75, 80, and 86. What mark must he get on the final exam? Remember, like the next drive or something, like when we started with mean, to get worth 40%, if he wants a final grade of 86. This is your mean, right there. This is the mean. So remember, we have tests like the score and the weight. Let's make a little table here. On the first one, we scored 75%, and it was weighted 20%. Then we scored 80, and that one was worth 20 as well. Then we scored 86. That was worth 20 as well. We're told they're all 20 at first. What must you get on your exam? This is our X, right? Which is worth 40%. You kind of have to fill in the blank, like what is that exam score? Guess what? You're gonna apply the same first steps. Okay, MAD. You're gonna go 20 times 75 is 1500. 80 times 20 is 1600. 86 times 20 is 1720. X times 40, 40x, or we normally go 40, then x times 40, it doesn't matter. So that is the first part of this. This is our unknown. I'll give it a different color. Let's go pink here. Right? We're trying to find what is that supposed to be. Okay. What is the average we want? We want 86, correct? So you go like this, 86%. And here you have to be a bit careful. We are going to add up all of this. Okay, that adds up to 4820. So the numbers we have, we add them up. So we go 4820 here. Plus, we also have to add up this product here, which we don't know what X is just yet. And what am I dividing by in this case? It's percentage, right? I check the weights. 20, 20, and 20, that's 60. 40, that's 100. So this is without a doubt a divided by 100 situation. Okay. And then you basically isolate here. So the mean we got from our question itself, right? That's the score you're after. So let's go ahead and undo what's happening to x. The first thing, what's the first thing I should do? I would always say, even if you're post-secondary, whatever you're doing after, you're going to do math courses most likely, get rid of what's dividing. So I will multiply both sides by 100. Okay. And the reason I'm doing that is because I want to get rid of this 100. I want to be able to do this on the right-hand side. On the left-hand side, it's 100 times 86. You're left with 8600. And on the other side, the brackets are gone. Perfect. What's the next step? Don't go right near x, right? Try to get rid of what's in front of it. So we're going to go minus 4820 and do the same thing to the other side. And we're doing that so we can say that this is gone. And on this side, all the actual math happens on the other side, right? You're left with 3780. And you're down to 40x, right? Bless you. Now you want to get rid of what's right in front of x, so we divide by 40. We divide, okay, not subtract. And so we can get rid of the 40 here and the 40 there, leaving us with x on that side. And we go 3780 divided by 40. We need a 94.5% on that final. Okay? Possible? Is it possible? The answer is yes, since less than 100 is needed, right? If you need 100 or less, it's still possible. Is it likely? No. Based on previous scores? Not likely. Okay, so likely? No, since the highest score has been 86%. Okay, so what's that? Nothing? Nothing you want to share? Okay, so I will say this. Page 43 has more. And I invite you to try page 45 to 48. That is just a general review of everything we've done. I will post the key to this as well. So I'm going to tell you already what's happening tomorrow. I'm going to give you some weighted mean, percentage, repetition, and a backwards question like this. Okay? What's that? Yeah. That's why I'm giving you a heads up. So give that a try. You still have 10 minutes or so. You can try that.